All right, thanks everyone for joining. We're just going to wait another minute or so to allow more people to dial in. So we'll start in 1 minute. Thank you. Okay, well, welcome everyone, and thank you for attending our webinar, The State of Hybrid and Multi-Cloud, Key Management and Application Challenges. My name is Lucy Temprano, and I will be your moderator today. Please submit any questions you may have in the chat window, and we will answer them at the end of the presentation. So let's move on to our presenters. Our presenters today are Michael Osterman of Osterman Research and Michael Hughes of Unbound Tech. Michael Osterman is the principal of Osterman Research, one of the leading analyst firms in the messaging and collaboration space, providing research, analysis, white papers, and other services to companies like Dell, IBM, Proofpoint, Commvault, RSA, and many others. Michael Hughes is a chief business officer at Unbound and has over 20 years of software sales and executive management experience. He's led 6 different software companies to successful acquisition or IPO, including Bonfire Interactive, Watchdocs, and Watchfire. I will now turn the presentation over to Michael Osterman.
Well, Lucy, thank you very much. And I'd like to thank everybody who's here with us today. I think we'll be able to provide you with some very useful information and maybe a new way of thinking about how you can secure hybrid and multi-cloud environments. So a little bit about Osterman Research so you understand our perspective in all of this. We're an independent market research and consulting firm, and our focus really is on the way that people communicate and collaborate. So obviously we focus very heavily on cloud, but we also focus a lot on security because security is such a critical element of the way that people communicate and collaborate. And particularly this year, as we'll get into here in just a moment, security has been really a very top of mind issue for just about everybody out there. We do a lot of primary research with IT analysts, with decision makers and influencers, those in the security space and so forth. And really our goal is to understand mostly what's going on in mid-sized and large businesses. The company is about 20 years old and we're located in Western Washington, not too far from Microsoft's headquarters. So, we all understand the benefits of the cloud. I mean, organizations have been moving to the cloud for many years. We've seen a real acceleration this year for things we'll get into here in just a moment. But we all know why we're going to the cloud. There's an enormous elasticity, huge amounts of scalability, particularly if you're in certain industries like retail, e-commerce, and so forth that need this vast increase in capacity at certain times of the year. There's very little or zero capital expenditure in most cases, relatively low operating expenditures. There's secure multi-tenancy. We hope at least that it's secure. And then very fast failover. The cloud tends to be more reliable than on-premises infrastructure, really because we're dealing with carrier-grade infrastructure here. We're dealing with redundant data centers and multiple comm links into these data centers and so forth. And so organizations that are using the cloud are also in many cases choosing to use a private cloud. And they do that because it gives them the control that they would have as with their traditional on-premises environment. They get very good reliability so that they can maximize uptime. They get the safety of their sensitive and confidential data, which is becoming much more important over time if you look at regulations like the European Union's General Data Protection Regulation, or GDPR, the California Consumer Privacy Act, and so forth. Privacy is becoming a critical issue, largely because the penalties for having a data breach are so enormous now that organizations are looking to maintain very tight controls over how they protect their data. And also a private cloud can give you that real protection of sensitive and confidential data. It's not only the safety of it, but you also have the protection of it so that you know it's going to be secure. And those are really critical issues for decision makers as they consider cloud-based solutions. Now, 2020 has been, at the very least, an interesting year on a number of fronts. Obviously the pandemic and so forth, and then all of the ramifications of that. And it's been a really bad combination of things in the context of IT and security. We've seen this really enormous increase in the use of cloud services as tens of millions worldwide, literally hundreds of millions of employees who are now working from home, using primarily cloud services like Microsoft 365 and literally thousands of others, many of which were never sanctioned by IT. Employees were suddenly thrust into a new work from home environment, so they started using a lot of consumer grade cloud applications. They started using a lot of things that IT and security had really never contemplated before. And so that's created a number of security problems. In addition to the fact that now employees are accessing these cloud services on the same networks that are also supporting their baby monitors and their refrigerators and home alarm systems and the like. So we have a really bad combination. And then all of this is going through home Wi-Fi routers for which the default password has never been changed. So, it's all led to a very insecure environment for the cloud. And really it's insecurity on steroids this year, based on all of these employees now working from home in a way that was never contemplated before by IT or security. And based on our research before the pandemic, anywhere from 10 to 18% of employees were working from home. And that was usually, the occasional person, working, one day a week at home, maybe bringing work home and so forth. But now we've got, just in most companies, just about everybody working from home, particularly in the IT space or in the knowledge worker space. At the peak of the lockdowns, we're looking at, March, April timeframe, that was about 80% of employees that were working from home, up from anywhere from 10 to 18% before that. And it's still fairly high. In a recent survey that we did, it's currently about 60% of employees are still working from home. And that's expected to remain at a much higher level than before the pandemic started. We're seeing companies like Salesforce, for example, that are not going to require their employees to come back to work until August of next year. Lots of companies are allowing employees to do that because they have the infrastructure in place. They can still conduct business. Things operate relatively smoothly, but from a really diminished security standpoint in many cases. And work from home, again, creates these enormous security problems, as I mentioned. We're using the same home networks that access our personal stuff. And home networks and devices are notoriously insecure. There's a lot of consumer-grade stuff on these networks that's also impacting, our corporate data access and so forth. And what we've seen is that because the attack surface has grown so large, so quickly, that the attacks have grown exponentially. We're seeing huge increases in the number of phishing attacks, the number of ransomware attacks, and so forth. So these have been really serious problems for organizations to try to overcome. So what is the hybrid cloud? When people think of the cloud, they think basically, applications running in somebody else's data center. It's Microsoft 365, it's Facebook, Twitter, whatever. And those are cloud applications. But there's really an important distinction to be made between SaaS and cloud. SaaS is generally focused on an application that's running somewhere else. It's in a data center somewhere, it's in a vendor's data center, and all of the applications, all of the infrastructure, all the security is just managed by that provider. The cloud is really different, and it offers a unique set of benefits in addition to SaaS. Not that SaaS, software as a service, isn't cloud, it is. But cloud has a much broader set of ramifications. It's based on a specific type of architecture, and it consists of a variety of remote computing resources, things like storage, virtual servers, really all the other elements of a computing environment that are managed remotely, managed by another organization, and you can have a variety of cloud offerings. And it's really differentiated from just simple hosting or software as a service. And ultimately, true cloud enables hybrid cloud, which most organizations are moving to at this time. And multi-cloud is really what its name implies. It's too limiting right now to think about just the cloud because there are a lot of flavors, a lot of gradations of the cloud. And we're now really in an age of interconnected clouds. It's rare for an organization to have everything in just a single cloud. They're using multiple clouds, whether it's using Microsoft 365 in conjunction with Salesforce and a variety of other cloud services. The vast majority of organizations are now using a multi-cloud environment. Oh, excuse me. And so, what we're finding is that there are many, many clouds in use, and that's increased exponentially this year. There was a study done by a leading security firm, and they found that for the typical enterprise, there are almost 1,200 different clouds in use. And those can be, a lot of those can be things that IT is sanctioned, but most of them have not been. This company found that 93% of the cloud services that were in use in the typical enterprise are not sanctioned by IT. And that's particularly so this year as employees are working from home with a lot less supervision, a lot less oversight from their security department. And there are lots of public clouds to choose from. Obviously, AWS, Azure, Google Cloud, but also IBM Software and a lot of other cloud services out there. And many organizations are using multiple clouds, and they're interconnecting clouds, sharing data between them, and so forth. You can also build a private cloud at a data center that's either rented or owned by your organization, and a lot of organizations are doing that. Private clouds can also be built and operated by a cloud service provider. They can do that in a remote data center. They can even do it on premises. So we have a lot of different flavors of the cloud, and a lot of interconnection. A lot of different things are going on here. One of the issues that really is top of mind for a lot of decision makers is security, for obvious reasons. And we asked this in a recent survey, is security getting better over time? And so we wanted to investigate that in the context of malware infections that were occurring on the network, phishing attacks that were not being blocked by the infrastructure, but ultimately reaching end users, things like CEO fraud or business email compromise and so forth. And what we found is that for a lot of organizations, things are actually getting better. There are fewer malware infections getting to end users, fewer phishing attacks reaching them, fewer BEC attacks, and so forth. But ultimately, what we're finding is that for the majority of organizations, things are either just staying the same, staying as bad as they've always been, or actually getting worse in many cases. We're seeing, for example, a big increase in phishing attacks that are reaching end users, a big increase in business email compromise emails that are reaching senior executives, more ransomware, and so forth. So ultimately, what organizations are doing to protect their employees, their networks, their data, and so forth as they move to the cloud isn't fully adequate. There are a lot of security holes that exist. Things are getting better for a lot of organizations, but for most, they really aren't. And not to be a naysayer, but things are going to get worse. We're going to see more cloud integration attacks, particularly as there are more multi-cloud environments out there. We are seeing cyber espionage for hire, and we're seeing new techniques that are being used by bad actors, things like deep fakes. Certainly working from home is going to complicate things and continue to complicate things because employees are going to stay working from home for long periods. Nation state attacks, we're seeing an increase in nation-state attacks in many cases. There was an attack by Iran shortly before the election. There's going to be hijacking of cloud services, and then tuning of artificial intelligence and machine learning attacks to get more sophisticated threats into organizations, artificial intelligence poisoning, vigilant regulators and vigilant consumers, and then the whole attack surface expanding. And to go to the point of regulators, I mentioned the GDPR and the CCPA. These are two critical regulations that organizations have to deal with. And we're seeing more of these regulations around the world in countries like Brazil, Australia, India, a lot of US states, and so forth. And so it's not only that security is getting more difficult to manage and cloud environments are getting more difficult to manage, but the consequences of not doing these things well is getting exponentially worse. Under GDPR, for example, the minimum fine for a significant data breach is 10 million euros or 2% of the previous year's annual revenue. In some cases, that can go up to 4% or 20 million euros. So the consequences of a data breach, because of failed cloud security, what have you, can be really quite serious. And Michael, wanted to ask you at this point, what are you seeing? I mean, in terms of threats getting worse, what are your customers telling you? Okay, I think we maybe lost Michael's feed there for a moment. I'll just continue. So fundamentally, the bottom line is that cloud growth before the pandemic was really quite strong. I mean, we have seen growth in the cloud over the past several years, and particularly if you look at companies like Microsoft, they've been in the cloud now for over 20 years. They started offering a cloud version of Exchange going back to about 1998, and lots of organizations have been moving to the cloud, and it's really accelerated over the last 5 years, but particularly this year because of so many employees working from home and the need for organizations to remain more agile. And so there's going to be increased need for digital transformation, and really combined with this increasingly remote workforce that's operating in a fairly insecure environment. And it's moving a lot of organizations to the cloud so that they can remain more agile. And so that if there's another pandemic at some point in the future, which probably there will be, organizations are going to be better prepared to deal with that. The fundamental problem, though, is that as you move to the cloud, existing applications are going to need to be refactored so that they can operate properly in the cloud. It's not just a matter of picking up this application, dumping it into a cloud service, and now everything works just fine. It does need to be refactored, basically set up to work with that cloud environment. And that includes the processing of conforming to whatever cryptography standards are enabled by the cloud provider's key management system. So you need to be able to integrate properly with the KMS for the cloud providers in order for that application to work properly. And so that means applications need to be re-architected to use the cloud provider's KSM, and that creates some problems. Management of keys, for example, is turned over to the cloud providers. That's not really a good thing because that's critical data that you need to retain and manage yourself. Applications need to be rewritten for each cloud provider, and there can be quite a few. I mean, if you're going to be dealing with AWS and Azure and Google Cloud Platform and so forth, you need to be able to have all of these applications work properly on each of the different platforms, but they also need to be refactored for each of those platforms as well. And also key management can fairly easily become inconsistent between cloud providers, between geographies, particularly for multinational organizations that are operating different clouds in different environments. This becomes a real issue. And so the alternative is to use some sort of a cloud agnostic key management system that's going to work with multiple cloud providers so that you don't have to go through this process of refactoring every application for every cloud provider that you're using. And an agnostic approach has some real advantages. Each application has to be rewritten just for a single key management system instead of the KMS for each of the cloud providers you're going to be using. There can be much faster deployment of applications to the cloud, largely because you're avoiding the work of having to refactor for every cloud provider in every application. That gives you a lot more flexibility, and it also gives you more control because now the key control isn't handed over to the multiple cloud providers. You continue to manage it yourself. And there are some significant advantages in doing that, as Michael's going to get into here in just a moment. So in summary, we've seen over the past several years major migration to the cloud. That's accelerating this year, and it shows no signs of abating. We're going to see more and more applications and services go to the cloud. And that trend, again, is going to keep increasing until organizations are almost completely on the cloud, as we've seen with a number of mission-critical applications. And using a single key management system that will work with multiple cloud providers really is a lot more efficient. It can be much more secure, and it gives you a lot more flexibility and really helps you migrate more quickly to the cloud. Okay, here's our contact information if you do have any questions after the presentation. And Michael, I'm going to hand the floor over to you.
Michael, we can't hear you. Check your mute settings. Nope, we still can't hear you, Michael. Sorry, everyone. It looks like we're having some technical difficulties. Just give us a few seconds to see if we can sort this out.
Hey everyone, can you hear me now?
Yes, I can
Yes.
hear you.
Yes.
Very good. Okay, thank you. Sorry for the technical difficulties.
Michael, at least on my side, you're quiet again. Michael Osterman, do you hear him?
No, I don't. Yeah,
Okay.
you went silent after the first slide.
No, okay.
Oh, you're back. You're back. You're back.
Okay, very good. So let's talk a little bit about and introduce the audience to who Unbound is. So Unbound has been deployed by many of the world's largest financial services institutions, large technology firms. As you can see here, we're a very patent-rich organization with 18 patents granted, 8 pending. And we live by this ethos of transparency, such that all of our technology, given the nature of what we do from a cryptography perspective, is independently reviewed by computer scientists throughout the world. We've got an amazing set of investors, the most recent of which is Evolution Equity, which we announced today with the closing of our Series B round of financing. And we also have a lot of analyst validation. Not only are we a Gartner Cool Vendor listed on 5 of their hype cycles, but also, and I think this is very important for the audience to understand, we are a FIPS 140-2 Level 2 certified technology, the only virtual HSM to achieve such a certification. Well, let's dig into the problem that Michael teed up earlier. So realistically, what we're finding is that enterprises, independent of the movement to the cloud, have a very difficult time managing all of the cryptographic material across their sites, be those different data centers, much less moving to the cloud, in which you have to abdicate a large percentage of what you would like to control to the cloud provider. As Michael alluded to, the idea of actually refactoring an application to be able to deploy that application on one cloud provider is incredibly difficult and time-consuming. And that's primarily due to the fact that you have to understand what that cloud service provider's technology stack allows you to do from a cryptographic perspective. Do they have certain HSMs that only support a certain type of cryptography? How does their KMS actually work? Do they have an external KMS? And what we're finding is that clients of ours, the reason why, and everyone says they don't want cloud vendor lock-in, but the primary reason in which they actually are forced to lock into a cloud provider is once the development teams learn the technology stack for cloud provider A, they arguably don't have the time to learn that technology stack for cloud provider B or cloud provider C. I think the other piece, and we've found organizations that have been sometimes willing to begrudgingly accept the fact that, hey, I actually have to give control of the key material to my cloud provider, but all things being equal, they would much rather control the key that gives individuals or organizations access to their corporate data that's now being stored on the cloud itself. So if you think about it, so let's say I'm moving to Google or moving to Azure. What I need to understand organizationally is, okay, how does that system's KMS actually work? What are the HSM options that are available to me? Because they're limited, right? They're by definition allowed. What the cloud provider brings is what I'm allowed to code to. And what we've come to find is, and there's only one cloud provider that we know of that actually has an external key management system, and that's GCP. But inevitably, because the development teams need to learn these new technology stacks, what we're finding is that it does delay an organization's ability to get to the cloud as fast as they would like to. And as Michael alluded to, we're seeing that trend accelerate just due to the fact that people are not going to data centers given the pandemic. The other thing that's very interesting is the fact that there are the encryption standards that are the good ones that everyone knows about today, and a corporate policy says thou shalt write to the cryptographic algorithm, let's say RSA 2000. But at some point in time, that's going to change. That's going to advance. Maybe post-quantum computing will actually become reality, and you're going to need to implement a post-quantum algorithm. The challenge that we find is that because applications are hard-coded to the policy that's in effect now, it actually makes it incredibly difficult to revert to or to alter that when the policy is set in the future. And that typically requires a line-by-line search within code that is, again, painful, time-consuming, and not what development organizations want to be doing. They want to be developing the latest and greatest new functionality. Now, the thing that is very interesting is that if I develop my application to cloud provider A, if I need to go to cloud provider B, I have to go through this entire exercise again, right? I have to learn cloud provider B's technology. And now not only do I have to maintain that, each time I rev the application, I need to understand what changes have been made by Microsoft or Google on their back end from a key management perspective and alter my code accordingly, which creates a lot of operational complexity and, I would argue, unnecessary operational costs on an ongoing basis. And if we think about let's talk about the key management challenges associated with these. We deal with a lot of big financial services organizations that have very defined and strict policies on what cryptography they want to deploy and how it is that they want their applications to leverage that technology. The reality is that in moving to the cloud, you are confined to what the CSP's key management system allows you to code to. The other element that I alluded to is that I'm abdicating ownership and control of those cryptographic keys, and arguably the key policies, which I think is a really important and oftentimes misunderstood aspect of when organizations move to the cloud. I, as an organization, want to define my policy. I want to own my keys and manage my keys. All things being equal, if that were the data center, there's no way they would provide somebody access to cryptographic material. But by definition, because most organizations don't know there's a better way, they have to abdicate that control to the cloud service provider. And if you think about it, because different geographic regions have different regulatory regimes that they have to contend with, you have to organizationally have different levels of trust and HSM models that exist just simply due to the fact that, if I deploy to Microsoft or AWS, it's not as if that I get to apply it and say I'm going to use one policy across the globe. I'm very dependent on what the geographic and regulatory regimes are that what Google or Azure or AWS will enable me to provide for. And then, of course, I need to make sure that my applications are smart and nimble enough to be able to speak the KMS language of each, not just the HSM language potentially, but the KMS language of each cloud service provider. So typically we see that organizations are looking at this kind of heterogeneous hairball of choices that they can contend with, right? Which is, hey, do I go ahead and leverage the CSP's KMS? Do I try to create a bring your own key type of policy? But I would argue that if I bring my own key, I still abdicate control of that key to the cloud service provider. Do I go old school and just deploy it on an on-premise HSM, which arguably creates potential latency issues? Do I leverage based on the type of data, do I leverage the cloud HSM, or do I use some sort of third-party key management as a service technology? All of these complexities go into, trying to figure out what is the strategy. But I would argue that there is a better way that I'll explain in a moment. So if I look at the way organizations are contending with this challenge today, is they write their application and they are able to write it to these particular technologies. And so suddenly, if I want to be truly cloud agnostic, and to be able to deploy anywhere, my application has to be smart enough to contend with 7 different key management type of technologies. Now, that in and of itself makes my head hurt, and I know that when we're speaking to many of the enterprises that we're talking to, this is the challenge that they contend with. So the better way, let's talk about this, because what Unbound provides you the ability to do is effectively write to the Unbound platform, of which we are a cryptographic platform that provides the ability to consume cryptographic services that we are then able to translate to communicate to Google, to communicate with Azure, and to communicate with AWS. So what that enables you to do is if you write to the Unbound platform, your application is immediately cloud agnostic, capable of being deployed anywhere. Let's bring this one step further. We know that when you're contending with different cloud providers, the ability to actually replicate key material across from AWS to Azure, we just don't hear of organizations doing that. They find it very, very challenging to even consider doing that. But with Unbound, you actually have the ability, because the application is cloud agnostic, because our technology, the moment you create a key, it replicates across all of your environments, be those on-prem environments or cloud service provider environments. That application is capable of accessing the same data. So let's say that I'm in North America running in Azure, and I have a department coworker that's in Europe and they're running in AWS. We have the ability to actually execute the same application in 2 different data centers, which you think about a cloud service provider, Azure and AWS really are just data centers, as if we were running internally. We will handle the key replication. We will handle the translation of the communication to the KMSs, the HSMs, or in Google's case, the external key management system. So this provides a ton of flexibility to organizations because now their development teams can just learn one platform and not have to understand the detail associated with the cloud service providers' cryptographic capabilities. So graphically, let's talk about this. So organizations that we're dealing with are asking this question. Like, I would love to be able to manage cryptographic keys across all of my sites. And I know we've been primarily talking about cloud, but the same challenge exists on-prem, right? If I have an HSM estate, if I have different data centers, I still have this challenge of how do I manage these across all of the different silos that exist across the organization. One of the things that we were just talking about is if you talk to Unbound's KMS, not only is that application cloud agnostic, it's also immediately crypto agile. So what do I mean by that? I used the example earlier, which is, hey, we are deploying, the policy today says we will write to the RSA 2000 spec, but tomorrow it's going to be something else. What we are able to do is completely abstract the underlying policy from the application itself. So when your policy actually changes to some RSA 3000, some post-quantum algorithm, we will actually automatically facilitate the communication from the application to leverage that incremental algorithm without any changes to your code. Again, thinking about just operational expense, the pain associated with how you would do this today, we will completely abstract away from your developers. And then the last thing is this notion of, hey, we talked about BYOK, bring your own key, which is I create the key and I send it to my cloud service provider. That's the best organizations are capable of providing in today's environment. But what we actually provide is one step beyond that, which is not only do you bring your own key, but you are able to control your own key. So we haven't spent a lot of time talking about Unbound's, our underlying technology infrastructure. But what we do is we leverage a cryptographic algorithm called secure multi-party computation, which effectively allows me to create private key material in multiple parts. Those multiple parts can be stored in multiple locations. So let's bring it back to the cloud example, which is if I create the key on-prem or within maybe an IaaS environment that's controlled by me, and I actually am then capable of not sticking the entire key, but only sticking a piece of the key inside of the cloud service provider's KMS, they never have enough key material to be able to decrypt my data. What does that eliminate? It eliminates the ability for an attack on the cloud service provider to get access to my data. It eliminates the ability for the cloud service provider, if they're subpoenaed, to give my data to some nation state, as a for instance. And of course, it eliminates the ability for somebody who works with that cloud provider to access your data intentionally or inadvertently. So lots of benefits associated with this type of approach. I think the other thing that organizations would love the ability to do based on what we're seeing is to manage all cryptographic material, all the keys, all the certificates through a single pane of glass. So picture this, this environment shows on-prem, it shows cloud, it shows multiple cloud environments, but it also shows HSMs, right? So what Unbound has the ability to do is to leverage the HSM estates that you have today, because there's certain type of data that certainly needs to remain secure in a FIPS 140-2 level 3 or level 4 type of environment. We have the ability to integrate and communicate with those HSMs themselves. For the data that doesn't require 140-2 level 3 or 4, because we're 140-2 level 2 certified virtual HSM, you have an inherent advantage in how you deploy our technology, the ability to take an HSM that's software-based and put it on the edge next to that database server or next to that application server that provides you far greater performance than you're able to achieve with the centralized HSM infrastructure, much less the idea of replicating keys across data centers or across cloud providers. Unbound will handle all of that for you, so that you have the ability to define a set of key policies that you're able to uniformly apply across environments independent of whether it's on-prem or in the cloud. And due to the fact, the nature of what it is that we provide, every cryptographic operation is logged in a log file that provides a non-reputable source of truth, such that you're able to see beyond the shadow of a doubt what cryptographic function was performed by whom, at what time, against what application, or against what data. And then the last thing that I think is very, very important, and which is a very different thought, which is most of the time people are worried about key theft, because if I get access to the key, I can use that key in any lock that will accept that key. Well, because of the fact that we break the key material up into multiple parts, we're able to apply policy to that key material that says that, hey, Michael is only able to use this key to perform this function against this data set. If somebody else attempts to use that key material that is against what the policy states, there's the ability to have an alert sent out that provides to your SIM that will let you know of attempted key misuse. So I think there's significant benefits that organizations just haven't realized traditionally, that there's a better way to go about solving some of these big business problems when you migrate to the cloud itself. So with that, Lucy, I'll turn it back to you.
Great, thanks, Michael. And just a reminder to everyone, if you have some questions, please put them in the chat window. We already have a couple in there, so we can get started. The first question is, are encryption keys created in one cloud and replicated across to other cloud providers as needed?
Yes, as I stated during the course of the presentation, that is an inherently natural function within Unbound's technology stack. Whether you're Azure, AWS, Google, some Alibaba, right? The ability for us to simply recognize that there is another location that is connected to the Unbound cluster, and the key material will automatically be replicated to those different locations.
Okay, great. The next question, in GCP, are you saying that you are able to integrate with their infrastructure as a service, platform as a service, and SaaS environments?
That is correct. Given the fact that Google has an external key management system that we have integrated to, that allows an organization to deploy in their IaaS environment, for us to take advantage of Google PaaS services in which the company will still have the ability to control their own key, and the ability to integrate with SaaS applications that Google provides through their external key management system.
Well, that's all the questions that we received today. If anyone thinks of any questions that they would like to ask us after the webinar, please use that email address that's on the screen, contact@unboundtech.com. Michael, do you want any last words before we wrap up?
No, it's just a real pleasure being here. Thank you for the opportunity.
Thanks, Michael. Well, then, thank you everyone for attending. On behalf of Michael Osterman and Michael Hughes and everyone at Unbound Tech, we hope you enjoyed the presentation and have a great day. Thank you.